All right, so hi everyone, welcome back. A very good evening to you all, and myself Ayush Tripathi. Welcome you all to this post-analysis discussion of the last weekly contest 205. So let me just quickly share my screen. And before starting the discussion, just write a quick plus one in the chat box if I am audible to you. And this template seems good to me. So write a quick plus one as a confirmation from your side so that we can start the discussion. I got stuck in third question. No worries, Hemant. The third problem can be solved with the help of a dynamic programming. Anyways, starting with the first problem, you are given an integer array ARR and you are also given an integer k. And here your task is to find the length of the longest subsequence of ARR such that in the subsequence the ith element mod k should not be equals to I plus 1th element mod k. So that is two adjacent element must not have the same remainder after divided by k. And this is valid for all. This is for all the valid I. You have to return the length of the longest subsequence. And here we have the definition of the subsequence. So coming to this example, the value of k is equals to 2. So we can select all the three elements, right? That is 1 mod 2. It is equals to 1, then 2 mod 2, 0, then 3 mod 2, which is equals to 1. So that is 1, that is 1, 0, 1. And no adjacent elements are equal. So yes, we can select all the three elements in the subsequence. That's why our answer is 3. Now let me just quickly explain you this second example, 2, 7, 4, 2, 5, and 3. In the second example, the value of k, it is equals to 3. So let's first take the remainder with a 3 for all the elements. So after taking the remainder with a 3, that is ARR mod k. So this will be equals to 2, then 7 mod 3, it is 1. Sorry, 7 mod 3, yes, it is 1. Then 4 mod 3, again 1. Then here it is 2, and here also it is 2. So what I can do, I can select this element 2, then I can select this element 1, then another element 2, right? So the subsequence do not have any adjacent element equal. So that's why my maximum answer that I can have, it is equals to 3. The maximum length of the subsequence, valid subsequence. So I hope the problem statement is clear to everyone. Now the thing is how we can solve this problem. So let's consider an array, and after taking mod with k for all the elements. So let's say we have this array, that is we have a element x, then let's say we have element y. This is a remainder after divided the original element by k. Let's say again we have y, then let's say we have again y, remainder y, then let's say z, and then let's say 4 occurrences of y again. So this is a completely a greedy problem. So my claim is that it is always helpful to start with the first element. So always pick the first element in your answer, in your subsequence, and then check all the subsequent elements. So that is, I will always pick the first element and then simply check the subsequent element. So I will just simply check the next element whether it is equal to the previous one or not. So it is not equal. So what I will do, I will just pick this y. I will pick this element y. Now the next element y, it is equals to the previous element. So I skip all the occurrences of y. And the next different element, it is z. So I will pick this z, and then I will pick this y, and so on. So are you getting my point? What I'm trying to say? So my claim is that always pick the first element in your subsequence and then check for all the adjacent elements. If the adjacent element are not same, pick it, because it's a greedy approach, right? Our goal is to maximize the length of the subsequence. Our goal is to maximize the length of the subsequence. So that's why we always start with the first element. For example, let's say you have a x, then y, and then let's say again x. So it's instead of starting with the element y, we want to maximize the length. So we always start with the first element. So yeah, that's the approach. And now let me show you the implementation. So this is the method that you need to complete. So taken the size of the array, then update all the element by arr of I mod k. That is, take mod with k for all the element. Then initializing the answer with 0, and it simply says that we pick the element which is at index 0. Then iterate from index 1, and if it is not equal to the previous element, then pick this element also and increment your answer. And finally, we simply return my answer. So I guess it is a pretty straightforward solution. I don't think any further explanation is required for this problem. It's fairly easy. Now coming to the second problem, array game. So in this problem, Alice and Bob are playing a game with an array ARR, and they take turns removing either the first element of the array or the last element of the array and adding the value into their score. But here Alice has an advantage. She can shuffle the array before the game starts, and the game ends when all the elements are removed from the array, when the array becomes negative, empty, and the player with the highest score will win the game. And here Alice always take the first move, and then Bob will play the move, and alternatively. So that is, first move will be played by Alice, then Bob, then Alice, then Bob, and so on. And the moment when the array become empty, we need to stop the game. And the task is to determine if it is possible for Alice to shuffle the array in such a way that she will win the game. and we assume that both the players play optimally, both the player want to win the game, and return true if it is possible for allies to supple the array in such a way such that she can win the game. Otherwise, return false if it is not possible for allies. So let's take this example. Element 4, then 1, 1, 1. So the first move will be played by allies. So I guess this was not the initial state. So initially we have 1, 4, and then we have two occurrences of 1. So the first move will be played by allies, and then after the Bob will play the move, and allies has an advantage to shuffle the array. So what allies can do? Allies can simply shuffle the array in this way. That is place the element 4 at the front, then 1, 1, and the rest of the element. So what allies can do? Allies can just simply pick the element 4. Now she will add 4 in its score. Then Bob is restricted to place pick 1 because at both the end we have element 1. So let's say Bob decided to pick this element. So Bob will add 1 to its score, and then Alice will pick this one and add 1. Then Bob has only one option, that is pick the remaining element. So Bob will pick this element, add 1, and now the final score of the game, Alice will end up with the score 5 and the Bob will end up with the score 2. Right, and Alice has the score greater than the Bob's score, so Alice will win the game. So yes, there exists a strategy to win the game for Alice, and this is what the term optimal means. If there exists a strategy, then player must follow that strategy to win the game. We always want our opponent to lose the game. So basically, in this problem, we need to find only one strategy. We are not interested to maximize the score. We are not interested to obtain the maximum score. We're just only interested to win the game and not just like to maximize the score. So that's why we find only one strategy to have the score greater than the Bob's score. So find, this is the intuition. Find any one strategy to win the game. And the strategy will be sort this array in increasing order. Sort this array in increasing order. So let's assume that we have sorted this array in increasing order. So the first element, it is a of 1, and this a of 1 is the smallest element of the array. Then a of 2, a of 3, a of 4, a of 5, a of 6. So for a sake of simplicity, let's say in our array we have only 6 elements. So let's say we sorted this array in increasing order. That is a of 1 is less than or equals to a of 2, a of 2 is less than or equals to a of 3, a of 3 is less than or equals to a of 4, and so on. So what allies can do? Allies can pick the element which is this last element, which is the maximum element of the array. So the allies will pick this element a of 6, right? And the best strategy for the Bob is to pick the element a of 5, right? The best strategy to pick for the Bob to pick the element a of 5. Then what allies can do? Allies can pick this element a of 4 to maximize her score. Then Bob is restricted, not restricted, but it is best for the Bob to pick a of 3. Now Alice will pick this A of 2, and has only one option, so Bob will pick this A of 1. So what will be the final score of Alice? So the final score of Alice will be A of 2 plus A of 4 plus A of 6, right? And the Bob's score, it is equals to A of 1 plus A of 3 plus A of 5. And see, if the Bob will follow any other strategy, then he will definitely lose the game. Basically, this is the best score that Bob can generate. And the sum of this entire array is constant, right? And the expression which we have on the left hand side, it is having value greater than or equals to the expression which we have on the right hand side. That is a2 plus a4 plus a of 6 is greater than or equals to a1 plus a3 plus a of 5, and it is equal when all the element of the array is equal. And basically it is very straightforward and a super simple reasoning. So let's compare the element in a pair. So let first compare these two elements, the two maximum element of the array. So here the allies have the greater score, right? A of 6 is greater than A of 5. So basically what I'm trying to say, this A of 5 will be cancelled by this A of 6, and you will get some point in advantage. That can be 0. Now let's compare these two scores. So here we have A of 3 and A of 4. So obviously A of 4 is going to be greater than or equals to A of 3. A of 3 is always less than or equals to A of 4. So allies has an advantage. Now in this case also allies has an advantage. So when all the element of the array are equal, then in that case Alice and Bob will have the same score. And if we have any element which is if we have any element which is different from the entire array, then in that case Alice has the strategy to win the game. Alice's score definitely be greater than Bob's score. And there is an one edge case. Let's say the size of the array is odd. So this is n is equals to 6. So let's say the size of the array is a 7, or maybe I can say 5. So just for a explanation purpose, let's say 5. So A1, A2, A3, A4, and A5. So again, sort this array in increasing order. Then Alice will pick this A of 5. Bob will pick A of 4. Alice will pick A of 3. Bob will pick A of 2. And Alice will pick A of 1. So this is the score of Alice: A1, A3, and A5. And the Bob has a score A4 plus A of 2. And it is very clearly visible that is Bob's score is less than Alice's score. So here in this case, the score of Alice, it is A1 plus A of 3 plus A of 5. And this score is greater than, not even equals to. This score is always greater than the Bob's score, which is A of 2 plus A of 4. So this is the complete solution. If all the elements are equal, then check whether we have even number of elements or odd number of elements. So there is only one case in which the match can be draw when all the elements are same and the number of elements are even. So this is the only possible case when the match will draw. Otherwise, in all the possible cases, Alice has the strategy to win the game. And again, I'm going to repeat this thing. Do not get confused. We are not interested to achieve the best maximum score. We just only want to have the strategy to make my opponent to lose the game. I just want to have my score greater than the Bob's score. Nothing else. So yeah, that's the simple solution. So if the value of n is odd, so what I can say, if n mod 2 is equals to 1, then you always have the strategy to win the game. So return true. In the else case, simply check if all the elements are same, then in that case we have to return false. That is, we have all the elements same and even number of elements, so return false. And in the else case, return true if all the elements are not same. Alice has that strategy. So now coming to the implementation. So this is the method that you need to complete. So here I am simply checking if the number of elements are odd, then always return true. Otherwise, iterate over all the element and check if it is equals to the first element or not. And if it is not, then we do not have all the elements same, return true. Otherwise, return false. The time complexity of the solution is order of n with the constant space complexity. Now coming to the next problem. And this third problem was fairly interesting. So in this problem, given an array ARR of a distinct integer and two integers k and p, find all the divisors of d, find all the divisor d of integer p such that there exists a subsequence of array ARR with the length d, and here d is a divisor of p, and that has exactly k penalties. And here we have the definition of the penalty. So a penalty is counted each time the subsequence switches the direction. So whenever you switch the direction from increasing to decreasing or from decreasing to increasing, the value of penalty will increase by 1. So that is from increasing to decreasing or from decreasing to increasing. And the subsequence is increasing if each element is greater than the previous element, and the subsequence is decreasing if each element is smaller than the previous element. So moreover, you need to count the critical point. The initial direction is determined by the first two element of the subsequence. So basically you need to preserve the first two element to find the initial direction, and then whenever the direction will change, the penalty will increase by 1. So yeah, that's the simple definition of a penalty. And if the subsequence is having element less than 2, then it has the penalty 0, right? So let me explain you this example. So the value of p is equals to 5. So what are the divisors of 5 we have? So actually 5 is a prime number. So 5 has only two divisor, which is 1 and 5. So here basically we need to find the divisor. Find all the divisor of P such that there exists a subsequence of array with the length equals to D, and that has exactly length, that has exactly penalty K. So the divisor one, we need to check how many subsequence we would have, which is having length, 1, and the number of penalties is 2. So here the number of penalties are 2. So it is not possible to have any subsequence with the length 1 and penalty 2. So that's why we do not have any, we do not have a subsequence. So this divisor is not valid. Now coming to the next divisor 5. So the penalty that we are looking for, it is 2. So let us first find the draw the array for the given graph. So first we have element 1, and then we have element 3. So the first two element will determine the initial direction. So the initial direction is increasing, right? And then after this, whenever the direction will change, the penalty will increase by 1. So after this a 3, we have element 2. Now after this 2, we have element -1. Now after the -1, we have the element 0, right? So how many critical point we have? So this has exactly one. This has exactly two critical point. So this is penalty 1. So what I'm trying to say. So here the penalty will increase by 1, right? Do not get confused. The first two element will determine the initial direction, right? So penalty 1, and then here we have a penalty 1. So in total, how much penalty we have? So in total, the penalty, it is equals to 2, right? Which is equals to K, the desired penalty, and the length of the subsequence. So what I'm trying to say, consider the entire array as a subsequence, and it has a length 5, which is a divisor of 5, which is a divisor of P. So this is a divisor of P, and it is valid. So what you can do, just create an answer vector or answer array, create an answer array, and in that answer array store one element, which is 5. So I hope the problem statement is clear to everyone. Now let me just quickly draw some observation. So what are the observations we can make? So the very first thing, how many divisors of P are possible? So let me just copy the constraint here. The size of the array can be up to 100, and the element of the array from -1000 to +1000. And the value of k can be up to 10 power 5, and the value of p can be up to 10 power 8. So the size of the array can be up to 100 only, right? And the element value from minus 10 power 3. So the possible range for AR of I, it is minus 10 power 3 to plus 10 power 3. Then the value of k, it is always less than or equals to 10 power 5, which is very obvious. And the value of the value of a p, it is less than or equals to 10 power 8. So now one thing you can observe, it is not possible to iterate over all the divisor of p, because the divisor of p is greater than 10 power 5. So it is not feasible to iterate over all the divisors of p, as the value of p can be up to 10 power 8. So what observation we can draw here? So tell me one thing, what is the maximum possible length of the, what is the possible length of the subsequence with the penalty k? So if the if the penalty that we are looking for, if we are looking for the penalty is equals to k, so this is my first observation. If the penalty is equals to k, then length of the subsequence. So then the length of the subsequence, it is always greater than or equals to k plus 2, right? Because the first two element will help you to determine the initial direction. So that's why we need to preserve the two element. And if you are looking for the penalty is equals to k, then you need another k element. So that's why the length of the subsequence should be less than or equals to k. Sorry, the length of the subsequence must be greater than or equals to k plus 2. So what if the value of n, what if the value of n, if it is less than, if it is less than, or basically what I'm trying to say, the value of n should be always greater than or equals to k plus 2. And if it is not, then in that case you can simply return false. So I can write it this way. So if n minus 2, if it is less than k, then simply return false. It is not possible to have any subsequence with the penalty exactly equals to k. So this is my first observation. Now after this, my second observation is to find the maximum length of a subsequence. With penalty exactly equals to k. And let's say that length is equals to L. So let's say that maximum length, it is equals to x. Or I can use some other thing for a representation. So let's say it is equals to mx. So now my claim is that all the integers which are greater than or equals to k plus 2 and in the range and less than or equals to mx are valid, and if it is a divisor of p. So then the next step is to iterate over all the integer from k plus 2, from k plus 2, because this is the minimum length of the subsequence, from k plus 2 to this integer mx, and all the integers are valid. And now simply check if p is divisible by I. If p is divisible by I, then in your answer simply add this integer I. It is valid. So answer dot push this integer I, push back, or you can say add, whatever the language you use. So these are the two main observations to solve the problem. Because if you are having some length, let's say this is the first integer, then the second integer of the subsequence, and these two integer are help me to determine the initial direction. Then let's say third element of the subsequence, then what I can say, fourth element. And you don't need to worry about, because it is clearly mentioned all the elements are distinct, so you don't need to worry about the equal to wala case. So here in this case, what is the value of penalty? How many penalty we have? So in this case, the value of penalty +1 for here, and +1 for here, and +1 for here. So the value of penalty, it is equals to 3, and let's say the value of k, it is also equals to 3. So here what is the length? So here in this case, the length of the sequence, it is equals to 1, 2, then 3, 4, 5, 6, 7, 8, and 9. So the length of the sequence, that is value of mx, it is equals to 9, right? And my claim is that all the subsequence, not all the subsequence, so that is all the length which is in the range from, all the length which is in the range from k plus 2, that is 5, k plus 2, k plus 2 to this integer mx, all the integers are valid, all the integers are valid. So for this particular example, the value of k plus 2, it is equals to 5, and the value of mx, it is equals to 9. So all the integers which are in this range are valid. So yes, we can have the subsequence of length 5 with the penalty exactly equals to 3. So simply select these three element, then simply select these three element, and then select this one, and then select this one. And if you are looking for the length is equals to 6, so add one element. If you are looking for the length is equals to 7, add another element. If you are looking for the length is equals to 8, add one more element, and add one more element to have the maximum length. Now the thing is how we can find the maximum length of the subsequence with the penalty is equals to k. Now this is my new problem, or I can say sub problem. So for this thing, I can use a dynamic programming because the constraints are very small. The value of n can be up to 100 only. The value of n can be up to 100 only. So that's why we can use our dynamic programming. And this is very similar to the longest increasing subsequence problem. So use the dynamic programming, and this problem is very much similar to the longest increasing subsequence. So now this is my boiled up version of the problem. Find maximum length of the subsequence with penalty exactly equals to k. Now how we can do this thing? So for this for this let's define a state tp of I comma p comma flag, dp of I comma p comma flag. So in my implementation I have a different representation. So just listen to the explanation and go and try to solve it by your own. Try to implement it by your own. So it will return me the maximum length of the subsequence such that the penalty exactly equals to p, and the last order, the last order is either increasing or decreasing. So here the value of a flag can be 0 or 1. So this is my simple representation. If the value of a flag, if it is equals to 0, then it simply means the last order was increasing. The last ordering of the element was increasing. And if the value of a flag, if it is equals to 1, then it simply means the last ordering of the element is decreasing. So the current state, this state will return me the maximum length of the subsequence such that penalty is exactly p, and subsequence ends at index I. I decided to I decided to add the ith element in the subsequence, and the ordering will be equals to flag, or I can say direction. That would make more sense. And the direction is equals to flag. If it is 0, then increasing. If it is 1, then decreasing. You might have a opposite representation, that is 1 for increasing and 0 for decreasing. Cool. Now what will be the base case? So coming to the base case, dp of I, comma 0, comma flag. So here what does this 0 represent? So this 0 represent the penalty is equals to k. So in that case, the maximum length will be equals to 1. So at least we would have the length 1. That is pick the ith element. It is very straightforward. That is pick the ith element, and this is my initial condition. Pick the ith element, and the subsequence would have a length 1, and it has a penalty 0. It might be possible we update this value in future, but this is my base case. It might be possible that we update this value, because let's consider a subsequence which is of length 3. So here we have a subsequence of length 3, and it also has a penalty 0, right? It also has a penalty 0. So in that case, we update this value. But just for a initial condition, my minimum value will be 1, right? And after this base case, iterate over all the integer from 0 to n minus 1. Then iterate over all the possible value of a p, that is penalty. So for p is equals to 0, and it goes till k, right? You don't have to iterate over the values which are greater than k, because the maximum penalty that we are looking for, it is k. We don't have to go beyond k. Then possible value of flag, it is 0 or 1. So in my implementation, what I did, I hard check the value. That is, I fill for 0, I fill for 1. And now how you can fill this value? So to fill this value, iterate over all the previous integer from j is equal to 0 and till I minus 1. So iterate over all the previous integer, and then compare the value. Compare ARR of I and ARR of j. So this is an homework task for you. but what I believe, this is a complete solution. Now compare ARR of I and ARR of J, and then accordingly do some case work. So basically, what I decided here. So I decided the previous subsequence and at index J, right? And in that previous subsequence, I decided to add this element ARR of I. So my previous subsequence end at index J, and now I decided to add this element ARR of I. So now it's your task is to just simply check how the values are changed. So basically, if ARR of I, if it is greater than ARR of J, then what does it mean? It simply means the sequence is increasing. So it simply means the values are now increasing, right? And if ARR of I, if it is less than ARR of J, then it simply means the direction is now decreasing. The direction is decreasing, so simply add one penalty for the flag is equals to 1. Now let me show you the implementation also. So if the value of k is greater than n by 2, is greater than n minus 2, then simply return this empty answer. Then here is my DP array of size n cross k plus 1 cross 2. The possible value of a penalty, this is my index, and the possible value for flag. Then find the maximum length of the subsequence having exactly penalty is equals to k. Then this is my base case which I have explained you. Then I iterate over all the integer I, then all the previous index. My previous subsequence will end at index j. Then these are the possible value for penalty, right? And then simply compare the element at index I and at index j. And if it is, then now the current now the current subsequence is increasing, and otherwise the current subsequence is decreasing, right? So accordingly change the value. So here what I did in my implementation, I represented increasing with the flag is equals to 1, and I represented decreasing with the flag is equals to 0. But you can change the value accordingly and then find the maximum length. So I iterate over all the possible value and find the maximum length such that the penalty exactly equals to k, right? And then I iterate over all the integer from k plus 2 to this maximum length, and if it is a divisor of p, then add it in your answer and finally return this answer. The time complexity of this solution will be n square multiplied by k, and the value of n can be up to 100 only, and the value of k can be up to 10 power 5. Now coming to the last problem of the contest, minimum toll cost. So in this problem, in a city of a geek land, there are basically in a country of a geek land, there are n cities, and there are n minus 1 road connecting these cities. So basically you have a tree with the n node and n minus 1 edges. The roads are connected in a form of a tree, and the roads are represented by 2D array, and the road of I is basically a 1D array of a 2 integer u comma v, and indicating that we have an edge from u to v, and each city has a toll cost associated with it represented by a cost array, where the ith city has a toll cost of I. So cost of 1 will represent the toll cost for city 1, cost of 2 will represent the toll cost for the city 2, and so on. And you are also given a k coupon. Each coupon can be used to reduce the toll cost of a city by 10%. And you can only reduce the toll cost for a city by exactly one time. And also in a single day you can use at most one coupon on each city. If you are going to use another coupon, then come tomorrow or some other day. And here you are given a 2D array journey, and basically you have to complete all the journey which contain m journey of I comma journey of I is equals to c comma d indicates that the journey start from a city 1 to city c on a d day, on a day d, and your task is to find the minimum total cost you need to pay to complete all the journey. And answer can be very large, so written under modulus 10 power 9 plus 7. And if two journeys shared a partial path, each must be calculated from a city 1. So basically you have to consider all the journey independent. No shortcutting or no catching. So let me explain you with this example. So the toll associated with the node 1, it is a 10 unit, then 20 for 2, 30 for 3, then 40 and 50. So it has only one journey, that is from 1 to node 5. So there is exactly one journey from node 1 to the given node 5, and the number of coupons that we have, it is exactly equals to 2. So the value of k, it is equals to 2, and this journey will start on a day 1. So what I can do, let me just keep track of a journey. So there will be exactly one path from 1 to c. So that is 1 to 5. So from, because the given graph is a tree, so it is a tree, so there will be unique path from this root node 1 to the given node 5. So from 1 to 2 and 2 to 5. So in this case the cost will be the inner card cost, it is equals to 10, the toll for the node 1, or I can say city 1, then 20 plus 50, right? But here we have a 2 coupon which I can use to reduce the cost by 10%. So the best here is to apply the coupon at here, right? And if you apply the coupon at here, then you have to pay only 90%. So the 90% of this of integer 50, it is equals to 45. And then in this case, 90% of 20, it is equals to 18. So the total in occurred cost will be 10 plus 18, which is equals to 28, and 28 plus this 45, which is equals to 73, right? So my answer will be equals to 73. So I hope the problem statement is now clear to everyone. Now coming to some observation. So the very first thing, each coupon can be used exactly one during entire journey, or I can say during all the journeys. We can use at most k coupon. and each coupon reduce the price by 10% and exactly one time, even when you are applying for the same day. When you visit the city for the same day, there will be exactly one time you can reduce the price. So each coupon can reduce the price by 10% once in a day. So these are the two important things that I want to highlight from the problem statement. Now, how we can solve this problem? And it is comparatively easier than the third problem. All you need to do is simply apply our DFS traversal. So let me draw this graph. So let's say we have a node 1, then let's say from 1 to 2, then in 2 to 3, then 2 to let's say 4, and let's say 2 to 5, and let's say 6, and 2 to 7. So what I can do, first I'm going to calculate the initial path. So let me write the step. So the very first thing, plot the journey. According to their day value. Then after sorting this journeys array, what I can do, I can process all the journey which is on the same day. Now the thing is how we can process the journey. How we can process the journey. So initialize the answer with 0, and here in this answer, I will store the total cost without using a coupon, right? And then after processing all the journey, later on I will decide which coupon to use and where. So for this thing, what I can do, I can create a temporary array, and just for a simplicity purpose, let's say we have a two journey, and one journey from 1 to 5, or I can say 1 to 6. Let's say one journey is from 1 to 6 on a day 3, and another journey is from 1 to 4 on a day 3. So we process both the journey in a same iteration, in a single iteration, or I can say in a single DFS call. So for this thing, what I can do, I can create a array. I can create a array destination array, or you can also name this array as a visit. But in my implementation, I have used this array destination array, and this array is temporary array for every particular journey. And I will use another global array just to check how many time we visit the node in total. So for this destination array, for every journey which has the same day number, what I can do, I can just simply increment the value of a 6. So destination of 6 plus plus, and the destination of previously it was 0. Previously it was 0, and now it is changed to 1. Then destination of 4, previously it was 0. This is my destination node, and now it is changed to 1. How many journey we have which has this node as a destination? So then we can simply apply our DFS call. So basically this value is equals to 1. So plus 1 for here, and this value is equals to 1, right? So simply apply our DFS call with respect to this node 1. Then make a call with it all its a child. So come to this node 2 and come to this node 4, right? And then start returning the answer. Start returning the contribution of the node which is which is in a parent, which is in the path. So what I'm trying to say, from here this node 6 will return 1. That is value of the destination. This node 5 will also return 1, right? And this node 4 will also return 1 to the node 2. So basically here this value will change it to 2. That this simply means we visit this node 2 twice on a single day, right? One for the journey from 1 to 4 and another for the journey from 1 to 6, right? And this node 2 will return 2, will return this new value to its parent node. So its parent node is 1. So here now the value is equals to 1, is equals to 2. It might be possible when we have another journey 4 comma 3 and on a same day 1 1 comma 4 and or on a same day 3. So in that case what I will do, I simply increment this value by 1. Now it is equals to 2, and it simply means now this value has incremented by 2. Previously it was 0, and now this value will return 2 to its parent function. Now this value will be 3. That is, we visit node 2 3 times on a day 3, right? And this value will return 3 to its parent function. It simply means we visit the node 1 3 times on a day 3. It's a very straightforward. It is nothing but the subtree node sum, a very standard problem of trees. We have to count the sum of the subtree node and then return back to the parent function, right? And in this way we can calculate the cost, right? And how to calculate the cost? So since I know how many time I will visit this node, so for every node, just simply add the cost. And how much cost we can add? So let's say I decided to visit this node 3 times. So in your cost, simply add this count minus 1. So simply add this count, or I can say, yeah, simply add this count minus 1 and multiply it by the node value. So the current node value, that is the cost of node. So for example, the value of count for node 1, it is equals to 3. The value of count for node 2, it is equals to 3. Then for 5, it is equals to 1. And for 6, it is also equals to 1. Now some of you might ask that why count minus 1? Because at this point of time during the computation, I'm not going to use the 100%. I'm going to preserve one count because it might be possible when we decided to use a coupon at here, which I will decide later on. So in that case, I just only have to use count minus 1. For count minus 1, I need to pay the entire cost. And for one remaining, I will use a coupon. And if in a future it is not feasible to use a coupon at here, so in that case I will simply add the complete cost, right? And what I can do, I can also declare a, this is totally an ad hoc problem, or moreover I can say constructive algorithm and implementation based problem. You might have some different implementation, but I'm explaining my one, how you can solve the problem in my way. Then use another global array destination. So global array, and let's name this array as a dist, and it is of size n plus 1 because of a one base indexing. And if it is equals to 1, so basically distance of I will simply store the number of times we visited node I. during entire journey. And see, distance of I will be incremented by 1 for a particular day. So increment by 1 for a particular day. If it might be possible when on a same day you visit node I again and again, but the contribution will be 1 because we can use the coupon at most one time for a particular day. So that's why increment by 1 for every day. No, it is not dependent on a number of journey. It is dependent on the number of days. So increment by 1 for each day. It is independent of a number of journey, or I can say the number of time you visit the node on a particular day. But if it is at least 1, then increment it by 1, right? And then at the end, I can just simply check how many. I can just simply check how many time I can apply the coupon at here, right? And basically, let's say we have another journey which is from 5 5 comma let's say 4, right? So that is a visitor node 5 from 1 to 5 and on a day 4. So in this case, the distance of 5 will be equals to 2. Will be equals to 2. Let's say we have another journey. We have another journey from 1 to 4 on a day 2. So in this case, after processing all the day, the distance of the distance of a 4, it is equals to 2. That is, we visited 2 time on a day 3 and 1 time on a day 2, right? So I can use at most 2 coupon at here for the node 4. I can use at most 5 coupon. I can at most use a 2 coupon for the node 5, right? And then simply sort all the node based on their cost. Simply sort all the node based on their cost. And if it is required to pay the 90%, it then simply pick the node and apply the coupon, right? If it is having the maximum value, then pick the node, apply the coupon, right? And if you are not left with any coupon, then you have to pay 100%, right? Because here I have added count minus 1. So I guess that's a complete explanation. Now coming to the implementation. So this is the method that you need to complete. So first I have taken the number of node, or I can say, yeah, number of node, and then this is my number of journey. Then create an adjacency list, and this is my uh, distance array, the global array. Initialize all the value with 0. So yeah, this is my global array, right? And for every visit for a particular day, I'm going to increment the value of this node in my global array and initialize the answer with 0. Answer can be very large, so take a modulus with 10 power 9 plus 7. Then once I created a graph, then sort the journey based on their day number, right? And this is to keep track of the last day. And now I'm going to process all the day which are having all the journey which are having the same day, right? So keep on incrementing the journey number while the last day is equals to the current day, right? And then simply process all the journey which has the same day number. So process all the journey, and here I'm going to use the hand. I'm going to add the 100% cost by and going to add it for count minus one time, because one time it might be feasible to use a coupon, which I decide later on. And finally, I will return this count to the parent function. Then this is my distance array. If we are going to visit, then what I will do, I will simply add this cost. This is my 2D array just to decide whether to use a coupon or not. And these many times we visit the node during the entire journey. Then sort this array in a decreasing order, right? That is maximum element at the front, then second maximum element, and so on. So this is the value of C, which basically the node number, and these many times we visit the node. So first I'm going, whatever the coupon we are left with, we are going to use all the coupon, right? And use all the coupon and pay the 90%. And for the rest of the time, for the rest of the time, we have to pay 100%. So yeah, that's the complete solution. And finally, I can return this answer. So what I will suggest to you, Ashutosh, just go and try to implement it by your own, and then you can take the screenshot from this video. So yes, that's all about for the last weekly contest 205. Hope you have learned something new, and make sure to write your feedback in the comment box so that we can improve the upcoming problem set and upcoming session. And thank you everyone for watching this video and or stream. And have a good day. Good night.